Assalamu alaikum. Welcome back guys to another interesting lecture of engineering geology. My name is Engineer Abid Ali. I hope you all would be doing fine. Stay home, stay safe. Today our topic is about the sedimentary rocks. So in this video we are going to be talking about sedimentary rocks. So let's get started. Of course, as I mentioned, we are talking about sedimentary rocks, the second in a variety of rock in our rocks lecture. Please recall that rocks are classified according to the way in which they form. So like for example, igneous rocks form from cooling and solidification of magma or lava. So now sedimentary rocks form in an entirely different way, which I would like to describe now. The general way in which most sedimentary rock form is formed from the compaction and cementation of sediments. The general way in which most of sedimentary rocks form is from the compaction and cementation of sediments. Now there are some words that we need to talk about. First off, compaction means that what you might think, compacting, squeezing together. Cementation means gluing or cementing, sticking together sediments. But that brings up yet another question. So if these rocks are formed from the compaction and cementation, the squeezing and gluing of sediments, what exactly are sediments? Then sediments are the fragments, the little bits of rock that have been broken down as a result of process known as weathering. Weathering includes wind and ice, running water, etc. So imagine if you have a big boulder sitting in your backyard. Well, if you were somehow magically leave the earth and come back 10,000 years from now, the boulder might look very different as a result of fear of wind blowing against it and ice cracking it apart and water flowing over its surface. It will have broken down into smaller and smaller pieces. That's what sediments are. The small fragments that result from the weathering of rock, sediments interestingly are classified according to their size. So we actually have 6 categories of sediment sizes, the smallest being clay, then silt, then sand, then pebbles and cobbles. The boulders being the largest. So you have heard the term sand before. Now you actually just refer to a size of particle, not a specific material. You can ignore the graph portion of this chart as we haven't learned about it yet. However, I would like to pay attention to the names of the sediment sizes on the right hand side, so that I have highlighted in green. They will tell you how big each sediment is. So let's use sand as an example. For a sediment to be considered sand size, it would have to be between 0.006 centimeters and 0.2 centimeters. Anything bigger would be different type, as would anything smaller. Another example, boulders are considered any sediment that are larger than 25.6 centimeters in size. Let's talk about the first type of sedimentary rock, because there are really 3 types. The first type of sedimentary rock is called a clastic sedimentary rock. Now, a clastic is actually just a fancy word for a sediment. So these are actually types that we have already discussing. These classic sedimentary rocks form from compacted sediments, and these are generally classified according to their size. Let's take a look at the sedimentary rock reference table. Now, the classic rocks are the ones that are on the top half. They are also referred as the inorganic because they don't involve any living material and land derived, meaning they come from the land. They come from the rock that makes up the land. Now if you will notice under the grain size, you can see different size sediments that make up each rock. Composition tell us what mineral you would expect to see. So let's take a look at some of these. Classic sedimentary rocks, beginning with the first one, conglomerate. Conglomerate is composed of all different size sediments or class, compacted and cemented together. So you will have big cobbles, pebbles, maybe even boulders compacted with smart sand, silt and clay. Notice that the sediments in a conglomerate are rounded out, likely due to the flowing water that ran over them sometime in the past. Very similar to conglomerate is breccia. Breccia is made of all different size sediments compacted and cemented together. The difference between the sediments in the breccia are not rounded, they are more angular, pointy or jagged. Then we get to the sandstone. As you can imagine, sandstone is made of compacted sand grain, siltstone made of compacted silt, and shale made of compacted clay particles. So those are classic sedimentary rocks, compacted and cemented sediments. Now let's actually look at the other two types. We have organic and crystalline sedimentary rocks. For the crystalline, we have the things called evaporate and precipitate. Then for the organic, we have what we call biological matter rock or bioclastic rock. Let's talk about these as they are little bit more complex. First of the crystalline rocks seen here on the reference table. So these are under a column that says chemically or organically formed sedimentary rocks. So these are not necessary from compacted sediments. In fact, the crystalline ones form in an entirely different way. The crystalline sediments rocks are known as evaporate or precipitate. What that means is they form as a result some sort of chemical process. Let's take a look at some of the examples. This is probably the best example. This rock is rock salt. Now rock salt forms from seawater, which of course has salt or halite dissolved in it, and when that water evaporates, the salt stay behind in form of crystals. Those crystals are the rock salt. This is why it's called evaporate. This is also why it's called crystalline, because it's crystals of salt that were left behind after evaporation occurred. We also get another rocks type like dolostone that form in similar way. Just to mention the precipitate, this is similar process. However, as the name implies, it does not involve evaporation like rock salt does. A precipitate forms when a water sample is completely filled with dissolved mineral, so much that the mineral falls out being dissolved and crystallized in the bottom of the body of water. To summarize, the crystalline rocks all involves some sort of chemical process, whether it's evaporation or precipitation. The result would be rock salt, rock gypsum or dolostone. But what about these biological rocks, the bioclastic rock? Now these form from compacted organic material or organic matter. We already know some example of this, which include coal, which form from compacted plants remain, and then this, which is variety of limestone called coquina. You will notice that this is made of compacted shell of course are made by sea creatures. This is organic material and so being classified as bioplastic rock because it's organic matter that's being compacted together. One more key note about sedimentary rock is that they are only type of rock that may contain fossils or evidence of past life. So if you see a rock with a fossil in it, you know automatically it must be a sedimentary rock. The reason being the processes that involve the formation of igneous and metamorphic rock involve a lot of heat and pressure, and so these processes would destroy any fossil that existed. Therefore, the only type of rock that really commonly contain fossils are these sedimentary rocks. Okay, what is lithification and diagenesis? It is the process by which soft and loose sediments are converted into hard and firm rocks. Mainly there are three types, or you can say there are three methods. Number one is compaction or dehydration, What is compaction and dehydration? When a bed is buried under more sediments, it gets consolidated due to the high pressure of overlying mass. The excess of water is squeezed out and cohesion is developed between the grain of sediments. Fine grain sediments, for example, we have clay, are consolidated by this process. The second one we have is cementation. Cementation, when the coarse grained sediments, for example, we have like pebbles and gravels, are mostly consolidated by cementation. These being porous, water circulates through them and dissolved mineral matter may be precipitated between the grain, thereby causing cementation. The most common cementing material are silica, calcium carbonate, iron oxide, and clay minerals. We have an example is like conglomerates, we have discussed earlier in this lecture. The third one we have is crystallization, which is in which consolidation is caused by the crystallization of constituent sediments. We have an example of dolomite, limestone, gypsum, salt, etc. Structure features of sedimentary rock. The main sedimentary structures are visible features within the sedimentary rocks. They are formed during sediment deposition. The study of these structures reveals about their origin and helps in determining their age. The main sedimentary structures are stratification, lamination, cross bedding, graded bedding, mud cracks, and concretion. Now let's discuss them one by one. Number one, we have stratification. What is stratification? Stratification is the deposition of sediments into layers or bed is called stratification. This is one of the most commonly observed sedimentary structure. We have bed. What is bed? Bed is a layer of sediments whose thickness is greater than 1 centimeter. The plane dividing different beds are called bedding plane. Okay, what are the reasons for formation of stratification? We can discuss some of these. Like number one, we have is like the pauses in deposition that allow the older deposits to undergo changes before additional sediments cover them. Number two, the difference in the kind of material deposited, like shale and limestone beds. Number three is like the difference in the size of particles deposited, for example coarse grain and fine grain sediments. Number four, we have like the difference in the color of material deposited, like light gray and dark gray layers of limestone. Okay, the second one we have is the lamination and cross bedding. Lamination means layers of sediments whose thickness is less than 1 centimeter. These deposits are typically formed by fine-grained sediments such as silt and clay and often represent seasonal deposition. It is often found in fine-grained sedimentary rocks like shale. What is cross bedding? Cross bedding is current bedding or fast bedding. These are minor bedding or lamination which lie at an angle to the plane of general stratification. This structure is found in shallow water and wind-formed deposits. Number third, we have graded bedding and ripple marks. Graded bedding means when a sedimentary bed shows a gradation in grain size from coarse below to a fine grain soil is called graded bedding. Ripple marks are the wavy undulations which are seen on the surface of subsedimentary rocks. These are produced by the action of waves and current in shallow water and also by the action of wind. They are on small scale compared to the cross bedding. We have two types of ripple marks. Number one, we have asymmetrical or current ripple, which they can give an indication of wave direction, both water and in wind. Number two, we have symmetrical or oscillation ripple marks are formed when water moves back and forth in steady water environment like tidal. Number four, we have mud crack and concretion. Mud cracks are formed from the drying out of wet sediment at the surface of earth. These cracks form due to shrinkage of the sediments as it dries. The presence of mud crack indicates that sediments were exposed at the surface shortly after the deposition, since drying of sediments would not occur beneath the body of water. Concretion is a hard, compact mass of matter formed by the precipitation and cementing material within the spaces between particles in a sedimentary rock. Their shape may be round, elliptical, oval, or irregular. It generally consists of calcium carbonate or silica and often possesses an internal radiating or concentric structure. Like in this corner, as you can see, the example is like concretion in Kazakhstan. Okay, that would be all for today's lecture. If you guys have any questions, feel free to contact me. Stay safe, take care of yourself.